Once again, good morning to you all. So the topic that we are going to discuss is what syntactic specification of programming language. So the syntactic specification, which deals with some um, uh, we have some connection with the structure of compiler. So in structure of compiler, the second important phase. So out of various phases, total of 7 phases in compiler, this particular phase, which seems to be a very important one, syntax analysis phase. So this syntactic specification which relates to syntax analysis phase of your structure of compiler, and then the other name for syntax analysis is what we used to call it with some different terminologies as the tool is syntax analyzer, okay, which used to perform the syntax analysis process, and then otherwise we used to call it as a parser, okay. So it used to perform some parsing process over there, okay. So it used to take some input string, and then on that particular input string we used to perform some various parsing process. So we used to scan the input, and after scanning we used to frame some tree like structure. So the tree like structure we used to call it as a syntax tree, which is going to act like an output for us. So it's very simple, okay. So we are going to receive the input from lexical analysis phase. The input which is going to be in forms of pairs in the sense you will have the identifier number, identifier number, and then others used to call it as a token name with some values, okay. So identifier with its number, like serial number identifier with its number we are going to receive as an input, and using those identifiers and its number we used to generate, or we used to create some syntactic tree. Those syntactic tree we used to call it as a syntax tree, or else we used to call it as a parse tree. So the input which is going to be the keyword or token or lexemes, whatever that we are going to get from the first phase, lexical analysis phase. So that will be taken as an input, where syntax analysis phase it is going to receive those input. That after receiving those input, it used to create some syntax tree, or else we used to call it as a parse tree. The parse tree which is going to be the output of syntax analysis phase. So this particular syntactic specification of programming language which directly deals with syntax analysis phase. So to check out the syntax of your programming language, we are using this um, syntactic specification. We are using this, okay. So here we have a notation. Basically the notation to specify the syntax of the programming language, to denote the syntactic specification, we have some notation, or else we used to call it as a representation. So the notation that we are going to use over here is BNF or CFG, or else we used to call it as in grammar. Commonly we used to call it as in CFG. CFG stands for context free grammar. So that's very important. CFG stands for context free grammar, or else we used to call, simply we used to call it as in grammar, or else we used to call it as in BNF. BNF stands for Backus Nor Form, BACKUS NAUR form. So this is very important thing. uh, and then so similarly for lexical analysis phase we have what we have a notation. The notation we used to call it as a regular expression, so keep it in mind. So the notation which has been used as an input to your lexical analysis phase is nothing but regular expression. Similarly here in syntax analysis phase we are going to use some notation. The notation we used to call it as an CFG, context free grammar, or else we used to call it as an Backus Nor form, okay. And then here we have some advantages what we discussed in the last class. So it seems to be an easy to understand. So grammar, the grammar that whatever that we're going to use, which seems to be an easy to understand syntactic specification of programming language. And then second one, with this we could construct some efficient parser. The parser may be a normal parser, which is going to be an automatic parser. So using this grammar as a procedure, we would be able to construct some efficient parser. That's going to be the second important point. And third important advantage is, so generally it's going to give some structure to your program, and then automatically it's going to translate your that whatever that you're going to receive, and then it's going to translate that particular hierarchical tree structure into some object code. Okay, and then it also useful to detect some errors, because a syntax which deals with errors like syntactic error, we would be able to detect some errors. So we have some four advantages. Are the advantages are: the first one, which is in easy to understand syntactic specification. It's a grammar which is used to easily we could understand it to specify the syntactic specification, and then to construct some automatic parser or efficient parser we are going to use it. And third one, to translate it into an object code, we are going to use it for translation it into object code, we are going to use it. And then the fourth one, which is about detection of errors. So whatever the syntax errors that we have, to detect those errors, we are going to use it, we are going to use this. So so these are the various important things that we have related to your CFG. Okay, and then the next thing, which is the introduction to your CFG. So normally here we have some various simple statements, and then how we are going to convert those statements into an some more into an some more simpler form. Okay, we are going to take some simple statements, and then how we are going to convert further into some simplest form. So for that, we have some examples. As we discuss some examples, like if s1 and s2 are statements, and if e is an expression, then simply we used to write it as an if e, then s1 else s2. So instead of writing it as statement 1 and statement 2 and e as an expression, simply we are going to mention if e which denotes expression, and then s1 which denotes statement 1, and s2 which denotes statement 2. Okay, and then to denote some group of statements, we used to mention like this: s1 comma s2 up to sn. So you will have some set of statements over there. We are modifying it like begin s1 comma s2, you will have some various dot and sn. So this is an example, but here in the statement we have some ellipses to represent the etc. So we have some group of statements, and then to represent those group of statements we have some ellipses. For example, s1 comma s2, you have some various dots, and then you will have sn. Okay, Vinusri, move to the previous slide now. Vinusri, move to previous slide, please. Okay. See here in the third example, in this slide, you find the third example. Okay, okay, it's enough. Okay. So here in this example, see here, you have if s1 comma s2, you have some various dot which denotes what, which denotes etc. And then you will have what? You will have an statement. So here, see here in this slide, in the third row, you have a statement begin, statement semicolon, statement semicolon. You have some various dot and statement end. So this is the statement that you have. So here, usage of these dots in the statement, which is an avoidable one, we must not use it actually. So instead of using those dots, simply we are going to convert into an another form. So we used to call this conversion as rewriting rules or productions. Okay, so actually these dots which represents what? A group of statements. So group of statement could be called as what? Statement list. Okay, so that's it. So it's very simple. Those all those dots I'm going to take, and then I'm going to convert by using productions or rewriting rules. How I'm going to convert? I'm going to convert into another word. The word that I'm going to use here is statement list, because all those dots which mention what, which mentions a statement, group of statements, set of statements. So all those set of statements could be called as what? A statement list. So that's it. So see here in the fourth line, you have a statement begin. So all those statement which has been replaced with statement list, and then you have end. Okay, so it's very simple. So in this particular slide, the third line which has been replaced as the fourth line, the fourth line which replaced the third line. So in the third line you have what? Group of statement which has been replaced with a single word what? Statement list, by using the law or rule or rewriting rule or productions. That's it. And then where the statement list could have a single statement or group of statement. To represent it, we are using what? Statement list, arrow, a statement or statement list. Okay, so it could be a single statement or a group of statement. Okay, so all these things, you people may ask me, or you people have a doubt. So what these things denote? So you have some various simplest form like statement or expression, and then we are giving it as an expression plus expression. So what all these denotes? All these things which denotes which specify a production. So whatever the production that we're going to use, okay, so those productions which is it is being specified using this. So in grammar, so in CFG, in context free grammar, we have some set of productions. So using those productions only, we are going to check the syntactic specification of the program. Okay, so um, as I already told you what. So CFG, which is going to be the notation, important notation, which specify the syntactic specification of the programming language. The CFG, which is simply we used to call it as a grammar. The grammar, which used to consist of some n number of productions with it. Okay, we have some n number of productions. So all these statements, whatever that we have in the slide, which denotes productions. Okay, so using these productions only, we would be able to perform the parsing process. So whatever the parsing process that we used to perform, so all those parsing process which depends upon these productions. So this is very very important. Okay, so these are some examples of productions, and then so that's it. So move to next slide, please. Move to next slide. See here, this is very important thing. So grammar. So what is meant by grammar, and what are the various things that we have in grammar? Okay, so grammar, which consists of some four quantities with it, four important quantities. The first important thing is terminal, and then the second important thing is non-terminal, and third important thing is start symbol, START, start symbol, and then the last thing is about productions. Okay, so just we have some four quantities. The first one is about terminals, and second one which is about non-terminals, and third one which is about start symbol, and fourth one which is about what productions. So these are the four important quantities that we have in grammar. Okay, so based on these four quantities only, we are going to construct the entire productions. Okay. So these productions actually which consist of all these things. So grammar which consists of productions, and production which consists of these four quantities. Okay, so using these four quantities only, we are going to write all those productions whatever that we have for a particular expression, or for solving a particular parsing process. Okay. So the basic symbols of which strings in the language are composed are called what? Terminals. So in an expression, for example, a plus b equal to c, so or c equal to a plus b, so whatever may be the expression, so each and everything here which is going to be in terminal for us. Okay, so a is a terminal, equal to is a terminal, b is a terminal, plus is a terminal, and c is a terminal. So each and everything whatever that we have, which used to act like what? A terminal for us. Okay, so that's very very important. That's about terminals. And then we have things like a token, and then keyword, and then begin, else, punctuation symbol. So all these which denotes a terminal. Wow. So what are the token that your lexical analysis which is going to give, and whatever the keyword that we are going to find are like keyword like begin and else. So these are some keywords that we have, and what are the punctuation symbols that we are going to use. So all those punctuation symbols also, which comes under the terminology terminals. Okay, so we used to call these as in terminals. The next one is about non-terminal. Non-terminal in the sense which denote some sets of strings. So the syntactic variable or syntactic category, or which is going to be an example for non-terminals. So in productions, normally in productions we are going to use what? Both terminals and non-terminals, where these non-terminal which is going to act like an intermediate thing between the start symbol and terminals. So normally we have some two types of parsing. The two types of parsing are top down parsing and bottom up parsing. So we used to discuss about these two types of parsing in the upcoming classes. So here in the parsing process, normally we used to have an input string, and to that input string we used to perform some derivations using productions. Okay, derivations using those productions we used to call it as in grammar. Okay, so it's very simple. So normally in parsing process, we are going to check whether a particular input string is valuable or not. A particular input string is with syntax or without syntax. So like that we used to check normally. We are going to check the input string. So input string in the sense what are the output of your lexical analysis phase, that particular output which is going to act like an input string for us. Okay, so it's very simple. So we are going to take that input string, and then the next thing for that input string we are going to derive some derivations to check it out whether that particular input string is with syntax or not. We used to check it with some grammar. Those grammars which consist of what, which consist of some set of productions. So in those productions you have some four quantities. What are those four quantities? We have terminals, non-terminals, start symbol, and production. And then during the derivation process, the first thing that you're going to use among those four quantities is start symbol. So we have some four quantities. Among those four quantities, the first thing that we're going to use is what, we used to call it start symbol. From start symbol, further we used to use non-terminals, and further non-terminals will be converted into some other non-terminals, and finally non-terminals will be converted to terminals. So between start symbol and terminals, we used to have some various conversion of non-terminals to non-terminals to further some other non-terminals. So it will be like this. So you will have start symbol, and then you will have terminal at the start symbol at the top, and terminals at the bottom. So in syntactic tree or syntax tree, you will have start symbol at the top, and then you have terminals at the bottom. Between the start symbol and what you will have between the terminals, you will have some various non-terminal conversions, converting a non-terminal to some other non-terminals. So which is going to act like an intermediate product in the syntax tree or in the derivations whatever that you have for an input string. Okay, so it's very simple. So we're going to take input string from lexical analysis, and we're going to implement the syntax analysis process over here. And so we used to call it as a parsing process. So during this parsing process we are going to use a grammar, the grammar which consists of four quantities, and based on these four quantities we used to have productions, and using productions we used to construct some derivations, or we used to derive something. So after deriving something using those derivations, we used to construct parse trees. So in this parse tree you will have some start symbol, and then you have terminals at the bottom. Between the start symbol and terminals we used to have some various non-terminals, or a conversion of non-terminal to some other non-terminals. So that non-terminals which is going to act like an intermediate one between your start symbol and terminals. Okay, so that's the thing. And then the next one which is about start symbol. Start symbol, so one of the non-terminal which is going to act like what, start symbol. So you will have some various non-terminals in your grammar. So among those non-terminal, one of the non-terminal, only one of the non-terminal which is going to act like a start symbol. Okay, and finally the fourth one is about production. Productions in the sense the combinations of start symbols and non-terminals are combinations of terminals and non-terminals. So those things we used to call it as an productions actually. So those things is productions. So so here in this example, you have statement expression, statement links, or which is going to be non-terminal. So one of the non-terminal which is going to act like what, start symbol. And so the productions, so how we are going to frame productions, by define the ways in which syntactic categories may build upon from one another. So using some syntactic categories in the sense whatever the non-terminals that we're going to use. So from non-terminals we used to have, or we used to have some other non-terminals. So that's about built upon from one another. So non-terminals will be built upon from another non-terminal actually. And finally we will have terminals. Okay, so actually to form the terminals, finally we used to form the terminals which must consist of the input string whatever that you're going to parse. Okay. mm, okay, so move to next slide please. So these are the things about grammar. Move to next slide please. Okay, so these are some of the examples that we have. So productions which consist of non-terminal followed by an arrow is used. and then followed by a string of non-terminals and terminals. Okay. So the arrow in productions we used to have some arrows. Okay, for example, see here, statement which gives begin, statement list, end. So we used to use the arrow as the arrow which represents actually conversion or the transition, or whatever the conversion process that we have. Those conversion process, either we used to convert a start symbol to non-terminal, and non-terminal to further non-terminal, and non-terminal to terminal. So just you have three conversions over here: start symbol to non-terminal, non-terminal to some other non-terminal, and finally non-terminal to terminal. Okay, so these are the conversions that we have. So these conversions which is been represented using, are denoted using either arrow or either using double colon and equal to. So you could use any one of the symbol. So to show those transition, to show those conversions, we are going to use some two symbols here. The first symbol is arrow. Okay, the second symbol is double colon with equal to. So this is going to be the second symbol. So the production consists of a non-terminal, so you have an arrow, and then further you will have non-terminal or terminals. So that's the thing. So you have, this is the example. So here, statement which gives begin statement list. So this is going to be an example. And then see here, out of this we are framing some productions as statement list which gives statement or statement list. So it may be a single statement or group of statement. Okay, so here the statement list which is going to be a non-terminal, an stmt statement which is maybe a terminal or non-terminal. The next example is, you have an example to denote arithmetic operations. Okay, so in this example, what are the various symbols that we are going to use? ID is a symbol, plus is a symbol, and minus is a symbol, and asterisk is a symbol, and then slash is a symbol, and an opening bracket and closing bracket is a symbol, and then or, the vertical line or, which represents a symbol. And then with the production that we have here is E which gives, that's about EXPR. EXPR stands for expression. Okay, the E which gives E OPE expression. OP stands for operator and expression. So kindly concentrate on this example. So E gives E, OP and E. Okay, and further the E could be further converted into E with nested parenthesis, which means EXPR with nested parenthesis. Okay, and then E further could be converted into E minus EXPR. So that's going to be the next one. And then the last one is about um, E which gives ID. So these are some various things that we have. Where here in this productions, so E gives E OPE, E gives E with nested parenthesis, and E gives minus E, and then E gives ID. So among these things, so we have many non-terminals, and then the terminals here are the OP, which is going to be an terminal, and then ID, which is going to be the terminal. And remaining things, what are the remaining that we have? The E which is going to be the non-terminal, and E which is going to act like the start symbol, and then so that's it. So E which represents a start symbol, capital E. E stands for expression here, EXPR here. So E which represents a start symbol, or else we used to call it as a non-terminal. Okay, and then OP which represents operators. The various operators are plus, minus, asterisk, and then slash, which is going to be the various operators that you're going to use. So here in this production, E could be converted into four forms. The first one, what? Expression, OP expression. The second form, E with nested parenthesis. Third form, minus E, and fourth one, E could be converted into ID. Okay, so that's the thing. So here, move to next slide, please. Move to next slide. So that's it. So with this we are going to complete this CFG, context free grammar, but I would like to give some examples related to how an input string will get parsed. Okay, so for this you must have a pen and note with you. So for this you must have a pen and note with you. Okay. So how we are going to derive actually derivations, are how we are going to um, derive derivations for an input string, and how that could be converted into an tree structure, and how we are going to use the productions. Okay. So in the previous slide we have in production what E gives EOPE. Here E which represents expression. Okay, E gives EOPE, and then E gives what E with nested parenthesis, and then E gives what minus E, and then E gives what ID. So these are the four productions that we are going to use now. So the input string which is going to be just ID plus ID. The input string which is going to be what ID plus ID. So this is going to be the input string that we're going to use. Okay. So using these productions, how we are going to derive this input string ID plus ID, which is going to be the input string, and for this input string we have to derive some derivations using those productions. So in the previous slide you have productions. What are the productions that we have? E which gives EOPE. Okay. Expression which gives expression OP expression, first production. Second production, expression which gives expression with nested parenthesis. Third production, expression which is going to be a minus expression. Third production, expression which is an ID. So these are the production that we're going to use to derive this input string. So the input string is ID plus ID. Okay. So among this production we have to take a start symbol. The start symbol is E. The first one E which gives um, E, OP and E. Okay. And then further E which is an expression. Okay. And then instead of OP now I'm going to replace with plus, and I'm going to replace the E with E itself. So first I'm going to take the first statement, E gives E OPE, and in the next statement instead of OP I'm going to replace it with plus operator. So that's it. So the first statement is E gives E OPE, that's going to be this E which is in start symbol, and using that I'm going to start. And in the second statement I'm going to replace the OP with plus, and in the third statement I'm going to replace the leftmost E with ID. So you will have ID plus capital E. And in the last statement, I'm going to take the rightmost E and then I'm going to change it into ID. So you will have ID plus ID. So this is how we used to have the derivations. The derivations which is going to be in a way that E gives E OP and then E, and then you will have E plus E, and then you will have ID plus E, and then you will have ID plus ID. So first production, and then the OP which is been which must be replaced with some various operators. So OP which is replaced with plus here. So for that we must add in production, and then E which gives ID, and then finally the E which gives ID. Okay. um, Venusri, uh, Venusri, stop your presentation, so I'm going to present here. So stop your presentation, please. Instead of presenting, um, Switch camera. Mhm. Okay. Um, so is this visible to everyone? So is this visible to everyone? Okay. So this is how actually we have to derive something. So how to use the production and how to make the derivations. So see here. So here expr which has been represented here as capital E. Okay. So the first thing that we're going to do over here is the production, the first production that I'm going to use. The first production is what E gives expression, which gives expression OP expression. So instead of expr I'm using capital E here. So E gives EOP capital E. This is going to be the first production. And then see here further I'm converting this using some another production, which is another production here, where OP could be replaced with plus or minus or asterisk or slash or an exponential operator. So here the OP which has been replaced with plus. So in the second statement, what I'm going to do, I'm going to take the OP instead of OP, I'm going to replace with plus. So that's going to be in another production. And then in the third statement, I'm going to take the leftmost E, which is ID. That's going to be your leftmost E. So I'm using the production E gives ID. I'm going to convert that E into ID. So that's going to be the third statement. So in third statement, I'm using the production. The production is E gives ID. So using this production, I'm going to convert E into ID. So you will have the third statement ID plus E. And then the fourth statement, I'm going to take the rightmost E and then I'm going to use the same production. The production is E gives ID. And then now I will get what? Final thing ID plus ID. Now the input string is what? ID plus ID. And then using the grammar is nothing but whatever the production that I have used over here, those productions, which is an example for what? Grammar, a CFG in short we used to call it as a grammar. So using this grammar we are deriving the derivations, and then after using these derivations, finally we would be able to draft that particular input string. We would be able to get that particular input string. The input string here is what? ID plus ID, which is going to be the input string. So this is how actually we used to perform the derivation process. So in passing process we have derivation. So using productions we are going to derive these things. Suppose we won't able to derive something, and suppose using those productions, suppose if we won't able to derive those input string, and which is going to be an error over there. Okay. So that's the thing. And then for this we would be able to construct some parse tree, actually the parse tree, which is going to be like this. So for what we are going to do first, E. Okay. And then E could be like this, which is going to be like this, what? E, capital E, and then OP, and then you will have what? Capital E. And then further we are going to replace this with what? OP into as plus. Okay. And in the next step I'm going to replace this E with what? ID. And finally I'm going to replace this E with what? ID. And now finally what is the input string that we are getting over here? ID plus ID. So this is going to be the input string, and using this grammar or using this production we would be able to generate this tree. This tree we used to call it as an syntax tree, or else we used to call it as a parse tree. So we have an example for what we used to call this as what? derivations, and this one which is an syntax tree, and this the entire thing which is a production for us. This production we used to call it as an grammars. Okay. So this is how actually we used to use context free grammar. So based on this particular example, we have some various things, we have some various derivations. So the various derivations like top down parsing and bottom parsing, and then whatever the concept that you're going to learn in the entire second unit, which is based on these grammar, these productions and these grammar. So entire thing, the entire second unit, which is based on these derivations, productions, and then the syntax tree. Okay. um, so that's the thing. So we have 3 more minutes to go. So I would like to ask some a few questions, and then I would like to stop the presentation. Okay. So um, so the first question here is, so what are the four quantities that we have in CFG? Four quantities that we have in CFG. Four quantities that we have in CFG. Post your answers in chat box, please. Four quantities in CFG, context free grammar. What are the four quantities that we have? Post your answers in chat box, please. Four quantities of CFG. So Deepika, very good. Vinusri, very good. Terminals, non-terminal, start symbol, and production. Very good. So special appreciation to Deepika and Vinusri. So exact, that's the right answer. So we have four quantities: the start symbol, and then terminals, non-terminals, and then productions. So these are the four important quantities that we have. Okay. So second question is, one more have answered, Shruti have answered, and Manjula have answered, and Sindhu have answered. Okay, good. Okay. Next question is, what is the other name for CFG? So what are the other name for CFG? So what are the other names that we could use for to denote CFG? So post your answers in chat box, please. What are the other names for CFG? Context free grammars. So someone have posted answer. DB have posted the answer. Backus, not form, and grammar. Yes, BNF or grammar. So very good, Vinusri and Deepika, and then Shruti have answered it right. Very good. The answer is BNF or grammar, which is going to be the right answer for that particular question. Okay. Mm, okay, in grammar, the third question, in grammar, the productions always, it used to start with what? So in grammar we used to have a number of productions, but it used to start with what? The grammar we have some a number of productions. Start symbol. Very good. Very good. So Deepika, Shruti, and Vinusri, and Manjula, Deepak, Rohit, Balaji, Darshini, very good, very good. So special appreciations to uh, everyone, those who have answered it very correctly. The entire productions we have, but always we used to start with start symbol. So we used to have a start symbol, and then you have non-terminals, and finally you will have terminals. Okay, but collectively all these things only we used to call it as in production. So okay. Thank you all for listening patiently and for understanding the concepts clearly, and then uh, answering for my questions, all my questions. Okay. So thank you, students. Thank you. So with this I would like to stop the presentation. Thank you. Mm, thank you. Thank you all. Go for break. Thank you.